The forces acting on the retaining wall can be favourable or unfavourable to the stability of the structure. Favourable forces ensure the stability of the retaining wall, while unfavourable forces encourage the failure. The failure can be referred to the list of failure here, which include the overturning, sliding, settlement, and also structural failure. Each type of failure is related to the limit state design conditions as listed here, either in equilibrium and geotechnical, or structure. This leads to our next topic about the factor of safety. As there are favorable and unfavorable actions, applying the factor of safety of 1.35 GK and 1.5 QK across the board will not give you the most critical situations. For critical conditions, the factor of safety for the favorable forces need to be reduced, while non-favorable forces are to be increased. The factor of safety are given in this table. The load conditions are given here. Combination of the structural and geotechnical, and static equilibrium conditions. The factor of safety differ between the permanent actions and the variables. Regardless the leading variables or accompanying variable actions, the factor of safety are similar. Among each type of the actions, there are favourables and unfavourables conditions. For the situations number 1, which is the combination of structure and geotechnical, when the permanent load is unfavourable, the factor of safety will be 1.35. But when the permanent actions is favourable, the factor of safety is reduced to 1.0. As for the variable actions, unfavourable conditions will have a factor of safety of 1.5, but favourable conditions will disregard the leading variables. Same goes to the accompanying variable actions. In the checking of sliding and settlement, you may refer to the combination 1, and in the checking for the stability, you may use the condition number 3. The first two conditions are similar, and the conditions number 1 obviously is more critical than the other. Therefore, you may conservatively choose this.